Energy demand drives global logistics on a massive scale. Here, industrial precision meets the challenge of transporting vital resources. At this dedicated marine terminal, safe energy transfer is paramount. Heavy-duty loading arms connect the massive tanker to the refinery. This intricate network fuels global economies. Energy reserves arrive. Heavy marine arms connect. Massive pumps operate continuously, feeding the refinery. Giant tanks form the heart of this facility. Pipelines transfer millions of barrels daily.
We are ready to collect the sample at Point Bravo. Flow is steady, reaching the line now.
Crude oil enters the pre-treatment stage. Here, heavy pumps drive the crude through a series of heat exchangers. Separators then remove water and salts. Inside the refinery, the desalter is critical. It removes salts to prevent heavy corrosion. Electrostatic grids separate water from the oil. The desalted crude oil leaves the desalter. It flows through steel pipelines at high pressure. Pumps and control valves operate around the clock, heading directly to the preheating system. Desalted crude enters the preheating train. Shell and tube exchangers maximize energy efficiency. Pumps and control valves maintain continuous flow. These massive shell and tube heat exchangers are vital. Inside, crude oil is heated to extreme temperatures. This is precision monitoring at a massive scale, driving the modern refining process. Inside the refinery, crude oil is heated. Process tubes pass directly through controlled burner flames. This raises temperatures safely for separation. Inside the refinery, the crude distillation unit is the first major step. Heated to over 700 degrees, the oil enters the column. This continuous processed on boiling points. Inside the column, heated crude oil separates. Vapor rises through a series of trays. Components condense according to their boiling points. This is fractional distillation. Inside this column, crude oil is separated. Lighter components rise to the top section. Medium weight streams are drawn from the middle, while heavy oils settle at the base. At the top of the atmospheric column, vaporization is continuous. Overhead vapors transition through dense piping to the condensers. Light hydrocarbons leave the distillation tower. They travel to the gas recovery unit. Here, the naphtha range stream is withdrawn. It flows through a dedicated side pipeline. This stream moves directly to downstream units. Centered in the middle section, a dedicated pipeline withdraws the kerosene fraction, sending it directly to the treatment unit. Drawn from the lower side of the column, this diesel range fraction flows toward processing. Next, hydrotreating will remove sulfur. Heavy gas oil exits the distillation tower. It travels to the secondary conversion unit. Here, it is cracked into higher value products. At the base of the crude column, the heaviest residue begins its journey. Heated to extreme temperatures, it flows toward the vacuum unit for final conversion. Inside this towering column, crude oil is separated, drawing off streams ranging from light gases to heavy residue. Separate streams of kerosene and diesel flow continuously. They move through dedicated pipelines toward the storage area. Modern equipment ensures precision at every stage. Light hydrocarbon gases enter the recovery unit. Here, compressors and separators isolate valuable fuel components. This processing unit is the heart of the operation. Massive separators divide hydrocarbons into distinct streams, delivering fuel and vital feedstock for the industry. From the base of the crude distillation unit, straight-run naphtha is routed for processing. Massive reactors facilitate hydrotreating, ensuring continuous, clean operation. Inside this hydrotreater, naphtha is refined. Heated feed and hydrogen enter the reactor. This removes sulfur effectively. Clean hydrotreated naphtha leaves the unit, stripped of sulfur and ready for upgrading. It flows directly toward the catalytic reformer, where its octane rating will be significantly increased. This catalytic reforming unit is the heart of the refinery. It processes hydrotreated naphtha to produce high-octane blend stocks. Inside this catalytic naphtha is transformed. It travels at high pressure toward offsite tanks to create the clean-burning gasoline of tomorrow. Precision blending is the heart of modern refining. Separate components flow at carefully controlled rates. Automated valves and quality gasoline monitored in real time for op performance. Precision blending is the heart of modern refining. Multiple streams are combined to meet strict specifications. Precision is the heart of modern refining. Multiple hydrocarbon streams are precisely combined. Automated valves ensure delivering certified, finished fuel to the world. The distillation unit separates crude oil. This diesel-range petroleum flows through insulated lines. It moves directly toward the hydro-treating facility, removes sulfur to meet environmental standards. Inside this massive hydro, kerosene blends with hydrogen. Under high pressure, catalysts remove sulfur. Deep within the refinery, the hydro-treating unit completes its process. Pure, treated kerosene now leaves the unit, flowing through pristine pipelines. Deep within the refinery's reactor system, clean, hydrotreated diesel is produced, flowing through massive steel pipelines, heading straight for the massive storage. Heavy gas oil flows continuously into the refinery. It feeds the massive fluid catalytic cracking unit. Here, giant reactors break down the hydrocarbons. This fluid catalytic cracking unit is the heart of the refinery. It converts heavy feed into valuable lighter products. State-of-the-art controls ensure safe and efficient operation. Lighter hydrocarbons leave the cat cracker, flowing directly to processing units. Derived from the fluid catalytic cracking unit, gasoline-range hydrocarbons flow steadily, moving through a complex network of refinery pipelines. Automated valves ensure precision.
Hydrocarbon streams enter the unit. They are processed under strict control. Reactors remove sulfur efficiently. Pipeline is monitored. Pure gasoline streams flow out.
Precision is key in modern fuel blending. Automated valves control multiple streams, combining components to produce premium gasoline. Following precise blending, finished gasoline flows through the dedicated system. Clean pipelines deliver pure product. Separate streams of kerosene and diesel flow continuously. They move through dedicated pipelines toward the storage area. Modern equipment ensures precision at every stage. Quality control is critical. Each fuel sample undergoes rigorous testing. This ensures optimal performance and guarantees compliance.
All parameters are within spec. Gasoline, kerosene, and diesel are ready.
Copy that. Releasing to storage.
Inside the control center, real-time monitoring ensures peak product quality. Finished streams of PMS, kerosene, delivering safe, reliable energy to the market. Inside these modern facilities, continuous transfer is key. Premium motor spirit flows directly into massive storage tanks. ensuring a steady and reliable energy. The refined kerosene travels through dedicated pipelines. High-pressure pumps ensure a steady and safe transfer. This finished product meets strict clarity and purity standards. The finished diesel is transferred to dedicated storage tanks. Modern systems monitor the flow and pressure at every stage, ensuring a safe and reliable supply of fuel. Liquefied petroleum gas is stored in massive spherical tanks. These pressurized vessels operate under strict safety standards and gauges monitor the system at all times. Massive transfer pumps draw finished fuel from the storage tanks. They push gasoline, kerosene, and diesel through large pipelines. This terminal is the heart of regional fuel distribution. High-speed automated systems ensure precision, delivering diesel, gasoline, and jet fuel. Dispatch begins with precision at the loading rack. Massive loading arms connect securely to the tanker. Automated safety side proper grounding. Flow meters ensure an exact, seamless, and safe distribution.
Efficient automation drives the facility. Separate bays handle gasoline and kerosene. Continuous flow ensures peak distribution. This is modern energy logistics.
Following rigorous safety checks, the loaded tanker begins its journey, delivering finished fuel to the open market. At the loading terminal, precision is key. Dedicated loading arms ensure a secure transfer. Automated systems monitor every liter. At the loading rack, finished diesel is transferred to bulk tankers. Precision flow meters and grounding systems ensure safety and accuracy. Precision and safety define the loading of liquefied petroleum gas. Highly pressurized systems ensure a secure transfer. Modern filling stations require precise and safe fuel delivery. Closed-loop systems ensure that zero emissions escape during transfer. Every connection is strictly monitored, and safety is the top priority. Technicians ensure proper grounding. Rugged, liquid-tight hoses are locked. Fuel flows into the underground tanks. This keeps our world moving. From the fuels that power our daily commutes to the essential energy that warms our homes, petroleum products remain vital to our modern way of life.